Hi, so we're in lesson 40 in section B. We're going to talk about the laws of logarithms. So we understand how logarithms work. We know that the logarithm of the base, this is the answer and this is the exponent. Whenever we have, this is a generic format, the log of the base, that gives us the answer here. And then that's going to be the answer is the exponent. That's typically the way we are used to seeing them, or we're used to solving them like that. So now we're going to look at different formats to understand how to solve the different ones that we see. So the first one is the product rule, and the product rule tells us when it is that we need to multiply our logarithm answers. And that is when we have a plus sign between the logarithms. So when we have a plus sign, log b of m plus log b of the bases match, and you have m plus n, then you're going to multiply those together. And the reason for that is when you have like base 10 with an exponent of 2 times base 10 times an exponent of 3, what you end up with is the base 10 with an exponent of 5. And so that is why multiplication and addition are the same when it comes to logarithms. As long as you have that same base, then that is what you're doing. You are going to multiply m and n together to get your answer. Now the quotient rule tells us when we're going to be dividing those answers. And if you think about it, when you have 10 to, let's say 3, right here, right, 3, times 10 to the negative 2, what do we usually do when we have a negative exponent? Well, we convert it. We turn it into a division problem. So we would say 10 to the 3 over 10 to the positive 2. And that's what's happening here. We're taking this positive exponent, and this negative is being applied to the n here, which is the exponent, and we're turning it into a division problem. So we would take whatever this value is minus whatever this value is and put them in this division format to solve the problem. So now let's look at the power rule. The power rule it's a little bit confusing, but basically all you're doing is you're taking this exponent that is on your m, whatever this answer here is that has an exponent, you can take that and turn it into a coefficient that is being multiplied times this answer value here. And likewise, if you have a coefficient, you can turn it into the exponent on the m as you need to. So keeping those 3 rules in mind, you need to write all 3 of these down. Let me see if I can give you an example for the power rule like I did for the others. So let's say you have 10 to the 3rd, and then you have a power rule of 2. You would multiply those together, right? So that would be 10 to the 6th. So you're multiplying this times this, or this times this. Either way, it's multiplying exponents times each other. So that is going to give you that same power here. It's giving you a power on a power. All right, so let's do some practice problems and try these out. All right, let me set the page back. We're going to do 40.1. All right, and this one uses the product. Yes, this uses the product rule of logarithms. So we're going to solve the log of a with answer 4 plus the log of a with a 6 is equal to the log of a x plus 4. So remembering our rule, when we have a plus, this is going to be multiplication. So we multiply 4 times 6, and that is going to give us 24 is equal to, because all of these bases are being canceled, right? But because this is plus, where these exponents are being added together, they're being multiplied. So 6 times 4 is 24. X plus 4 is our response here. So 24 is going to be x plus 4, subtract 4 from both sides. 20 is the value of x. So we solved this logarithm pretty easily. It's not that difficult. Basically, all you're doing is you recognize when you have a positive or a plus sign here that you multiply these two numbers. You turn that into a multiplication symbol and you cancel out all of your like terms. You know, you factor them out. That's how you would solve one of those. All right, because of this, this rule tells us that if we encounter the expression that contains the sum of two logarithms, we know that the arguments are multiplied, and we also know that it needs to be a positive value. So when 20 is used in x plus 4, we get positive 24, so therefore 20 is acceptable value in this argument. So let's do 40.2. Let's clear the page. Again, logarithms are really kind of hard to deal with until you are in a situation where you actually know how they apply and how to apply them. If you're in a field of study or a discipline where logarithms come in handy, they make sense to the math that you're doing, it's a whole lot easier to understand. Just learning the basics of them without being able to apply them to a real life situation is kind of difficult to wrap your head around. But we're going to try. We're going to do our best. So 40.2, we have a log with a base of 4. That is x plus 6 minus a log with a base of 4. That is x minus 1. And that is set equal to a log of 4 with 5. So we can cancel these out. Recognize that these are exponents. This is a positive exponent. This is a negative exponent. This is the resulting exponent. So x plus 6, we're going to turn this. This is a negative exponent, so we're going to put it in the denominator. X minus 1 is equal to 5. So does that make sense? You took this negative exponent and put it in the denominator. So now you can resolve it. So x plus 6 over x minus 1, the easiest thing to do is to multiply both sides by x minus 1 to cancel this. So you end up with x plus 6 is equal to 5 times x minus 1. So that'd be 5x minus 5. So when I subtract 5x from both sides and I subtract 6 from both sides, what I get is negative 4x is equal to negative 11. And when I divide both sides by negative 4, I get x is equal to a positive 11 over 4. And because this is a positive value, we're good to go. All right, let's do 40.3. And we're going to do the power rule for exponents with 40.3, just to illustrate how to solve those. So we've got 3 times the log of b, that is x, is equal to the log of b, that is 8. So we are going to cancel this and this. This becomes the exponent here. X to the third power is 8. So now we need to find the variable here. We're gonna find this basically. Third index of 8. X is going to be equal to 2. That is how we would solve one of those. All right, so we move whatever the coefficient is to be the exponent of this variable, and then we use that index to put on a radical symbol to solve for x. All right, let's do one more. Let me clear this. We'll do 40.4 as our final one. This time we're going to write, let's see, I'll let you figure out which one we're doing. We have the log of 12. X is equal to 2/3 the log of 12 which is 64. All right, so 2/3 is a coefficient. So that means we can take this off and we can take this off, and we could say x is equal to 64 to the 2/3 exponent. So that means what we have here is x is equal to the third index of 64 squared. So if we square this and we take the third index from that, let me pull up my calculator because that's an awful lot to do in your head. So 64 squared with the third index is 16. So your calculator comes in really handy whenever you need to solve those. You don't just want to take my word for it. You can always solve it yourself like that. So you see how that worked. This fraction, when you have a fraction that is a coefficient here in front of your logarithm, it becomes a fractional exponent on whatever this number is. All right, the first one we had the exponent where we put it on the x, and we solved the number that was here. This time we had the fractional exponent on the number, and x was equal to solving that exponential or that fractional exponent application. That's the only word I can think of for that. So that's all we have for those three rules. Remember the product rule. Whenever you are adding logarithms, you're going to be multiplying the answer or the exponent. So that equals multiplication. Subtraction equals division. And a coefficient equals a power. All right, or you could say an exponent on an exponent. That's what a power is. All right, so I will see you. I've got some practice problems for you to do with this, and then I'll see you in 40C, and we'll finish up.